How we doing, guys? This is the last questions on the DEB mock junior cert paper. It's question 6 and it's the conics question. So we're given an ellipse and a portion of ellipse which is CB, and we're also given a parabola AE. We're also told that line AE is a tangent to the ellipse. And also take note, they have said that we need to show clearly all constructions and the points of contact. So we're actually going to have to construct this tangent. Yes, it is a horizontal line, but we're going to have to, we can't just draw that horizontal line, we're going to have to show the construction for finding that tangent. So what we're going to do to find that tangent is we're going to find point A first, and then we're going to apply the construction to find that tangent. First things first, take note of how the question is laid out, and we're going to work our way down through the question. So they're mentioning the curve CDE is a semi-ellipse, so we're going to construct the semi-ellipse first. We're given a point M on the ellipse, and we're also given, we're actually given the, we're getting half the major axis, which allows us to find the full major axis, obviously. So we're going to have to construct a little, we're going to have to basically show our knowledge here to find this, when we have this point M, but we're not given the minor axis, obviously enough, so we're going to have to try and find the minor axis, and we're going to apply the concept where look, we'll go ahead and I'll show you, but basically what I want to say is we need to find the major axis, and when we find the major axis, that'll help us find the minor because we have a point on the curve. So I'm going to go ahead and start anyway and talk through it. Yeah, so first things first, I'm going to draw the semi-ellipse. I'm going to ignore that horizontal line AB first. I know the first thing to do would to draw that AB, but because it's a tangent, I'm not going to draw it just yet. I'm going to try find this ellipse first. So first things first, I'm going to try find the axis, and I know it's at 75 degrees. So I'm going to use my protractor to find 75 degrees first and take it from there. So I'll just set up the question for myself. Now, okay, 75 degrees. So now I'm going to draw I'm actually just going to draw it using a pencil to start us off. So if you have your books, it will be no harm to look at the ellipse chapter, which is page 199. It would help us, or help you as you go along. So I'm just going to draw a horizontal line nice and light. This is not the tangent now. This is not the tangent, so I'm just going to draw, yeah, about there. Alright, so horizontal line nice and light. Okay, so this is just to help me with that 75 degrees. That is not the line AB. So I'm going to choose this point here, and I'm going to go off at 75 degrees. Okay, so as always, anything in red is construction, black is heavy, and then blue is instruction. So that's a 75 degree line there. Alright, so I'm just going to, yeah, so I'm going to choose, will that be alright? Yeah, that'll be low enough. Yeah, so I'm going to choose that point there, the bottom of the line, and that is going to be D. Alright, so that's going to be the vertex of my ellipse. So there's D, and we're told our minor axis, or the major axis, sorry, is 90 mil. So see in the question just there, you have the 90 mil going from that point D. So I'm just going to measure back 90. So when you measure back 90, that is the center of the ellipse. Okay, and from there we can draw our major circle, because that is our major axis, 90 mil. So I'm just going to draw my major circle. Alright, and that'll get us going. So extend my compass, the length of the center to D, and just draw a circle. So that is my major axis. Okay, that is the major circle, and that is the major axis from there out. Okay, so I'm told my point M is 56 that way and 28 down. So I'm just going to go perpendicular to that 75-degree line. I'm actually just going to put a line through the center of the ellipse. And we know our minor axis is perpendicular to our major axis, so we can actually put in the major axis, but we don't, or the minor axis, sorry, but we don't actually know the length of it. Alright, so somewhere along that line there is the minor axis. So it's somewhere there, we don't know where. So we're going to locate that point M. So we're told it's 56 out the minor axis, so measure out 56. There you have it, and we're told it's then 28 in the way. So we can use sliding set squares again. I'm just going to set up a line perpendicular, or that's parallel to my major axis again, and I'm going to measure 28 along that. So it's 28 along that line. Yeah. Okay, so there's my point M. Alright, so that's a very important point. There's M. Okay, very important point. Now, where do we go from here, I hear you say? So we're going to apply, I want you to go to page, yeah, if you can go to page 202, okay? So if you go to page 202, you'll see under more problems to an ellipse. So the first example here, when you see, so when we're given, so this point here, for instance, point P in this on page 202, when you go parallel to the minor axis, so see that little arrow there, it's going parallel to the minor axis, so it's going up towards the major circle, and where it hits the major circle, they just joined it back to the center of the ellipse. And we know then if you come from P parallel to the major, you will intersect that line DC, and that is a point on your minor circle. Okay, so at the moment what we have is our major circle. We do not have our minor circle, but we do have a point. So that's my major axis. So my major axis is like this. So I need to go perpendicular to my major axis from M. Okay, so we're used to having the ellipse, the major axis being horizontal. So I'll actually show you a little sketch. So if we have we're given our major axis like that, okay, and we're given a point P out here, and we're told that point P is on our ellipse, okay, and I'm just going to draw my major circle, for instance. Alright, it's only a sketch, so it's not going to be perfect, and there's the center. Okay, so if that's our major circle, that's our point P, so that is on our ellipse, and we don't have our major circle, our minor circle, sorry, this is our major axis. Okay, so for this instance, the shape of the ellipse is going to be something like that. Alright, so this is what we're normally used to with the axis horizontal. Okay, so what we do in this case is we go vertical, which is perpendicular to our major axis, and when you hit the major circle, go towards the center, okay, and then from point P, we're going to go out the way. That there, from there to the center, is the radius of our minor circle. Because if we construct a circle, I know it's not a great circle now, but if we were to construct a circle there, like that, so what we did in this case is we went up to the major circle, and then we went back towards the center, and then from our point P, we basically came in towards where our minor axis would be, and there's our minor axis there. So that black line there represents my minor axis, and that's our minor circle. So what we have to do in our case, so basically the situation we're given here is our axis is like that, and our point M is somewhere over here. So if there's M, alright, so back to our question, there's M, alright, there's our major axis, what we need to do is go up towards our major circle, so up here somewhere, join that back to the center, okay, and no, sorry, our point M is somewhere here, isn't it? Yeah, so that's not point M, that's point M. Point M is not on the minor circle, it's on the ellipse. So what we need to do is, when we have our point M, we need to go towards our major circle. Okay, so here we're going to go towards our major circle. When we hit our major circle, we're going to go towards the center. So that's what we did here. And from our point M then, we need to go parallel to the major axis, and that will intersect, and that will be the minor circle. So I'll just do it here for you and show you. So from point M, you want to go away from the major axis towards the major circle. So there's my major axis. So I'm just going to go perpendicular to that, away from it. Where I hit that major circle, I want to join it back to the center of my ellipse. So there you are. So I joined it back to the center. And from point M, you want to come parallel to the major axis. And you found we've actually done that already to find M. And where they intersect, that point there. So see that point there, that is a point on our minor circle. So what we can do is we can extend our compass and just draw a minor circle. So what we did there, from M, you want to go away from the major axis up towards the major circle. Where you hit the major circle, bring that back towards the center of the ellipse. And then from M, you want to come parallel, so that line there is parallel to the major axis. You want to go parallel to the major axis, and where that intersects, that line, is a point on your minor circle. So that is the minor axis found, and that will allow us to draw our ellipse. Pretty simple now. Right, so I'll just extend our axis out there. Lovely. And what we've actually found by doing this is point E and C, and I'm just going to label those over here. So there is point E, because we know E is the point on the minor circle, and it's the top of the minor axis. And then point C, which is also important for the question, is just there. So it's where the minor circle meets the minor axis, just there. Okay, so that's E and C found, and we can go ahead and actually draw this ellipse now. Okay, so we need to use 60-30 to draw our ellipse, but note that the axis is at 75 degrees. So let me do this. So you want to set up the so you want to set up your 60-30 so it's parallel with the center axis. Alright, and you want to just go off at your 60-30. Okay, and that way as well. Actually, I have to do that one because you have M, that'll help you. So you want to set up your 45-degree set square so that it's perpendicular to the major axis to find those 60-30s. So what I did there was I just set up my largest point to my 60-30 set square, brought in my 45 underneath it, and that allowed me then to draw my 60-30 whilst incorporating that 75 degrees that we came off at. Okay, now our next step is to try and complete this ellipse. So what you got to do is, our rules are, when we hit the major circle, go towards the major axis. So I'll do that there now. But firstly, you want to go set up your set square so that it's parallel to the major axis, and then go perpendicular. So this here is our, I'll just draw it, that's our major axis. So you want to go towards that when you hit the major circle. So major circle, major axis. That's our rule, isn't it? And the other rule is when you hit the minor circle, go parallel to the, or go perpendicular to the minor axis. So there's our minor, and those lines that we brought out, when they hit our, so these 60-30s that we brought out, when they hit our minor circle, go perpendicular to our minor axis. So we're hitting the minor circle there, and then I'm going, there's my minor axis, I'm going perpendicular to that. The minor circle here, and what you found is we've located points on our ellipse. So that is a freehand curve. So we're going to go ahead and draw that. Alright, so the ellipse should go through point M, because obviously that is a point on our ellipse. So incorporate point to M when you're drawing your ellipse. There it is there. And then just go over in heavy just to finish it off. Right, so that's our ellipse drawn. So just to show you again how I found each of those points. So when I hit the major circle, go towards the major axis. And when you hit the minor circle, go towards the minor axis, or away from the minor axis, sorry, so we're going in that direction. And where they meet is a point on your ellipse. So towards the major circle, when you hit it, go back towards the major axis, and then when you hit the minor circle, come out, and that will meet a point on your ellipse. Okay, so that's our ellipse EDC drawn. So the horizontal line AB is a tangent to the ellipse. So I'm going to go ahead and I'm going to draw that tangent to the ellipse. So a little bit of help here would be to go to page 209. Okay, so if you go to 209 and just have a look at example 1. Now, that point P, point outside the curve, I'm going to say that is point, can we do that? Yeah, can we say that's point A? No, I can't. Okay, we find our, yeah. Okay, so what we have to do is, it's not example 1, it's actually example 2 we're going to use. Yeah, so have a look at example 2 on page 209. So it's this example here. So here we're given a line at 30 degrees. Okay, so that's going to be our horizontal line. So we need to draw a horizontal line. So if we were to show you like that almost, so we're going to have to draw a horizontal line a bit below, and we're going to have to bring our focal points perpendicular to that line, and where they intersect the major circle, that's going to be our points A and B, and we're going to have to draw this radius here, including focal point 1, bring it back to focal point 2, and that will be our point of contact. Okay, so I'll go ahead and show you, and yeah, we'll try to explain as best we can. So we need to draw a horizontal line just below the ellipse. Do not draw it right up on top of it, and I want you to draw it a bit away from it. Alright, so horizontal line. Now, next step, we need to find our focal points. The rule to find our focal points is half the major axis, and the top and the bottom or the minor axis will intersect the major axis again. That'll be our focal point. So we need to take the distance of our minor axis, or half the minor axis, I should say. No, I'm wrong. Half the major axis from the top and the bottom. Okay, sorry, yeah. So it's half the major axis. So half the major axis axis, scribe an arc back onto the major axis. So what I did there to find the focal points is I took half the major axis, so from the center out to D, go to the top or the bottom of the minor axis and just scribe an arc back onto the major axis. And what you found is focal point 1 and focal point 2. So that's F1 and F2, and they're very important for this question. So looking at page 202, the first thing we're going to have to do is bring our focal points perpendicular to that horizontal line. Alright, so they can just be vertical because we know that it's horizontal. So bring both of those. Okay, lovely. And where we have intersected the major circle, going to focal point 1, you want to get your compass and extend it back to focal point 1 from the major circle, sorry. So when you've joined it back to focal point 1, when you hit the major circle, you want to extend it back to hit focal point 1, and you want to scribe a semicircle. Alright, there's a full circle, it's another one. And yeah, so that is now point, if you're looking at page 209, that would be point C of the construction. And you want to join that back to focal point 2. Okay, just like that. And where you hit the ellipse, that's our point of contact. So just to reiterate what I did there. Drew a horizontal line. I didn't measure, I just came down it. Looks about 45 mil. Doesn't matter. And I found my focal points first, obviously. And then you go perpendicular to that horizontal line. So they're just two vertical lines. Okay. And I then got my compass and I identified where my focal point 1, so that line there, where that hit the major circle. I extend my compass back to focal point 1 and I drew a circle. Alright, or you can draw a semicircle, doesn't matter. Once you locate this point C. So point C is taken that radius. So I went and found where my line from F1 to this random horizontal line hit the major circle, took that distance back to F1 and just swung an arc back the way. And where that hit that vertical line is point C. Join point C back to the other focal point. Okay, and where that line intersects the ellipse, that is your point of contact. And then you can go ahead and draw your tangent, which is the line AB. Okay, and we know it's a horizontal line. So there is parallel, right? Because they're horizontal. And there's the point of contact, and I've labelled it POC as well. So it'll be a good idea to do that in the exam. Alright, so if you're a bit stuck on what I just did there, go to page 209, and it is example 2 there. Alright, so they've given you a 30 degree line, whereas we just have a horizontal line, and the ellipse is at an angle. Alright, so it's the other way around. Alright, next step. So we need to find, so that's the horizontal line AB to tangent. We found that. So the curve BC is the curve BC with vertex at B is an identical portion of the same ellipse. Okay, so we need to draw a portion of this ellipse here. Alright, so using C as our vertex. So I'll firstly try and locate B anyway. So what I'm going to do is come vertically down, because, yeah. Isn't it? Yeah. Which vertex B as identical. Okay. So come down vertically from C, and to locate B then what I'm going to do is I'm going to take that distance C down to where it hits that horizontal line. So that distance there, I'm going to take that and I'm going to come back along my ellipse and try locate how far out to come for that point B. So taking this distance C to our new horizontal line that we just found using the tangent, so taking that distance on my compass, I'm going to step back from D, right? Alright, so step back along our major axis. Alright, so step back along your major axis, and you want to come out then perpendicular to the major axis until you hit the ellipse. And you know what? They're actually, funny enough, they're actually the exact same as that point we found from using M. Alright, so that's obviously an inkling that we're going in the right direction. So what I did there, I'll use green just to help us because that's a bit tricky to understand. So we're told that the curve BC, curve BC with vertex to B is an identical portion of the same ellipse. Okay, so what I did was I came vertically down from C. So that distance there in green, I stepped back that same distance over here along the major axis. So step that back that same distance. So that distance there is that distance. Okay, and then to find how far out to find that point B, I basically came perpendicular to the major axis here until I hit the ellipse, because we're told it's an identical portion of the ellipse. So I stepped out that far. Okay, so stepped out until you hit the ellipse, and when you hit the ellipse, take that distance, and you just want to mark that down here then, and that's your point B. So from the center of the axis out to where you touch the ellipse, where you hit the ellipse, and just measure it out along that horizontal line, and that is B. Okay, so that's our point B, and now we just need to find this curve. So what we can do is we can just take points on our ellipse. So 2 points is loads, so I'm going to take this point here on our ellipse. So we're 60-30, where we use our 630, so find this point and this point. So I label that, I don't know, R and S. Yeah, so I probably should be doing it on the other side. So I'm going to label these R and S. I'm going to use this side because the curve is going like that, so it'll obviously sit like that. So to find that distance R, so I'm just going to bring those points to the axis just to show you why now in a sec. So bring those points R and S to the axis. Right. So this point, the R and S, I need to try and find those 2 points over here. So I'm going to call that S1, that distance from D back in as far as, so remember D is our vertex here and C is our vertex for the identical portion of the ellipse. So I took that distance S1 and step it back along C. Okay, and I'll come out. I use a horizontal line here, actually wrong line. So that's where S1 hits. So out here, I'll just step out and come off it then here off our actual ellipse. That distance, how far S is out, come over and basically stick it down there, and that there is S. Alright, so it's in the same list. So what I took there was from our vertex S1, there it is there, identical, and then from our axis stepped out S, 2S using our compass, and then just applied it over here. So I'm going to do the same procedure for R. So I need to come along my axis, however far R1 is. So from the vertex, measure out until you hit that line that R is on. Step down that distance over here. Bring it out, because I don't know how far out I'm going with R. So I just stepped out, and now I'll find how far out it actually is over here. So that's R there. Bring it over. That is now R over here. And what we can do is we can go ahead and draw the portion of the ellipse now. And there you have it. That is the portion of the ellipse. So just to reiterate what we did there, was we needed to locate how far away S was from the vertex. So stepped along the major axis, that S1, applied that here, and then we need to find how far out S was. So see that little line there, that distance out to S? I just applied that same distance over here as my compass, and then it's the same procedure then for R. Okay, so lovely. Next step, we need to find point A. AE is a parabola. So we're told the point A is 80 out from where E is. So I'm going to step out 80 and I'm going to use the rectangle method. So this is the method we'd be most familiar with. So I'm going to use that as my rectangle. We're going to have to divide this side into a number of equal parts and this side into the same number of equal parts. Okay, so first things, I'm actually just going to draw the baseline just to okay, so that's the baseline. Sorry, that's point A. That's point E up here. So what we're going to have to do now is find the curve of this parabola. So we're at 31 minutes. So you guys should be trying to aim for about 30 to 35 minutes for this question. So I'm going to go ahead and divide this top part into 4 equal parts. Or will it be? Yeah. So as always, any distance on my compass and mark it off 4 times. So vital part here is from the last point. So we marked 4 along that random line at any angle, back to the end of the line. Do not go to a random point. All right, do not. I've seen a couple of you doing the last week's question, and you went to a random point in the line. When you mark off 4 times, or however many times you want, join it to the end of that line. Then you got to slide your set square parallel to that line you just drawn. Bring those in. All right, parallel. Same situation going off that other line on the left hand side, any angle, mark it off 4 times, 1, 2, 3 and 4. Same thing here from the last point you've made. So from that last point, hopefully it'll focus. So from that last point you made, you need to join that to the end of the line, so which would be A in this case, and then you choose sliding set squares to find the rest of them. Okay, so you see they're divided into 4, and I'm just going to number them. So I always see my vertex as being my goalkeeper. Goalkeepers are normally number 1, so I'll number my points 1, 2 and 3 because they're close to the goalkeeper. Here again, this is close to the goalkeeper, so 1, 2 and 3. Okay, those that are closest to the vertex or your goalkeeper, you want to bring them parallel to the axis. So I'm just going to bring these vertically down because my axis is actually vertical. And those points which are opposite the vertex or furthest away, you want to bring them back to the vertex. So pass the ball back to your goalkeeper if you're on the wing in danger, is the way I try to remember it. So these numbers 1, 2 and 3 are on the wing. Whatever way you like to remember it, and where those points, so where those lines intersect. So you'd see now why I've just numbered them. So where 1 intersects number 1, that's a point, 2 intersects 2, and 3 intersects 3. Alright, so there are 3 points on my curve, and you can go ahead and draw that curve then. And there you have it. That's the parabola completed. And that's coming in about 35 minutes, and that's with talking and some, yeah, so that's what you should be aiming for. Yeah, I'm pretty sure the question is completed. So we've shown our instructions. No harm if you want to just highlight that point of contact a bit more. POC, so that's our point of contact there between the tangent and the ellipse. So yeah, that's it. Thanks for watching. Thank you.